negative, etc. Carbanions, species with a negative charge on carbon atoms. Molecules with lone pair such as NH3, H2O. Molecules that contains pi bond between carbon atoms. Organic reaction site. Electrophilic sites. Electrophilic site are molecules with low electron density around a polar bond. A hot spot for electron to attack. Examples of electrophilic sites in organic molecules: carbonyl, haloalkanes, hydroxyl compounds. Nucleophilic sites. Nucleophilic site is molecules with high electron density around the carbon-carbon multiple bond. Examples of nucleophilic sites in organic molecules: alkenes, alkenes, benzene ring, and etc. Reactions in organic compounds. There are 4 general types of organic reactions: addition, substitution, elimination, and rearrangement. Addition reaction. All parts of the adding reagent appear in the product. 2 molecules become one. Characteristic reaction of compounds with multiple bonds. There are 2 types of addition reaction: electrophilic and nucleophilic addition. Example: hydrohalogenation of alkene. HBr is added to an alkene, which is unsaturated, to produce a haloalkane, which is saturated. Example: electrophilic addition. Hydration of alkene. An electrophile, water molecule, is added to a nucleophilic site. Carbon-carbon double bond. Electrophilic addition. Reactions involving carbon-carbon double bond and carbon-carbon triple bond. Pi bonds are electron-rich and located above and below the plane of the bond, thus susceptible to attack by electrophiles. Example: carbon-carbon double bond, which is rich in electron and acts as nucleophilic site, reacts with electrophile, which is electron-poor species. Nucleophilic addition. Most common reaction of aldehydes and ketones. Nucleophile approach to the electrophilic site of carbonyl group. Example: in carbonyl compound, the carbon is bonded to oxygen, which is electronegative. Make the carbon site becomes delta positive and serve as electrophilic site, thus susceptible to attack by nucleophile. Substitution reaction. Reaction involving 2 reactants exchange parts to give new products. Characteristic reaction of saturated and aromatic compounds. There are 3 types of substitution reaction: A. Free radical substitution. B. Electrophilic aromatic substitution. C. Nucleophilic substitution. Example of substitution reaction: a nucleophilic substitution. Free radical substitution. Most common reaction of alkanes. Occurs with the presence of sunlight, UV. Example: halogenation of alkane. Alkane, which is saturated with no functional group, react with nonpolar molecule, chlorine. 1 hydrogen atom from methane is substituted by Cl from the chlorine molecules, resulting in a haloalkane formation and HCl. Electrophilic aromatic substitution. The characteristic reaction of all aromatic compounds. Benzene has 6 pi electrons delocalized in 6 pi orbitals that overlap above and below plane of the ring. Thus, benzene is nucleophilic site, which is electron-rich and susceptible to attack by electrophiles. Example: bromination of benzene with the presence of catalyst. One hydrogen atom in benzene ring is substituted by Br from bromine molecule. Produce a haloalkane and HBr. Nucleophilic substitution. Nucleophilic substitution is the most common reaction of alkyl halides. Haloalkane, where the carbon is bonded to halogen, serve as electrophilic site and susceptible to attack by nucleophile. Example: hydroxide ion, OH negative, a nucleophile which reacts with iodomethane, undergo substitution reaction by leaving iodide ion as leaving group. Elimination reaction. Opposite of addition reaction. A single reactant splits into two products. From saturated become unsaturated. Method for preparing compounds with double and triple bonds. Example: haloalkane undergo elimination with the presence of base to produce an alkene, which is unsaturated, and with a small molecule, HBr eliminated. Example: an elimination reaction. Rearrangement reaction. A reaction in which a single reactant undergoes a reorganization of bonds in atoms. Example: 1-butene undergo rearrangement to become 2-butene, with the presence of acid as catalyst. Example: rearrangement reaction.